In this class, we will be doing some exercise problems based on the surface area of a sphere and the surface area of a hemisphere. Okay, this is from chapter 11 of your textbook, and this is from exercise 11.2. We are going to do some problems from exercise 11.2. Now, I'm not going to be doing all the problems. I'll be doing sample problems for the basic ones, and the more difficult ones I will be solving each of them. So let us start with a simple problem, and the first question in the exercise asks us to find the surface area of a sphere for different values of radius. So I have just picked up one of the values of radius being 14 centimeters, and we have to find the surface area of the sphere. So we know the formula for the surface area of a sphere is 4 pi r square. For the hemisphere, we have two types of surface areas. One is the curved surface area, the other is the total surface area. So the curved surface area is half the surface area of a sphere, so it is 2 pi r square, and the total surface area is for the hemisphere is 3 pi r square. Okay, we have just recall these formulae. So now we are going to apply the surface area of a sphere formula here, so which is 4 pi r square. So the surface area of the squares of the sphere is 4 pi r square. The value of r given is 14 centimeters. So we have 4 into pi is 22 by 7 into r square is 14 into 14, and we can cancel out one of the 14 here because the 14 can be divided by 7, so 7 will go there 2 times. So we get 4 into 22 into 2 into 14. So let me write that, which is 4 into 22 into 2 into 14, and that gives a value of 2464. Okay, so 2464. So the surface area of the sphere of radius 14 centimeters is 2464 centimeter squared. Okay, so very straightforward, very easy. The radius is given. We just have to substitute the value of the radius in the formula for the surface area of the sphere. Let's do another example where instead of the radius we are given the diameter of the sphere. So we know that the diameter is 2 times the radius, or conversely the radius is the diameter divided by 2. So we are given the diameter of the sphere to be 14 centimeters in this case. So radius is half the diameter, so it's d by 2, that's 14 by 2. So we get the radius as 7 centimeters. From this we can now calculate the surface area of a sphere, which I will write as surface area. I'll just write it as SA. SA means surface area of a sphere equals 4 pi r square. So we will substitute the value of r here, which is 7, and the value of pi is 22 by 7 into 7 into 7. So one of the 7s will cancel out, so we will have 4 into 22 into 7, and that will give us an answer of 616 centimeters square. So the surface area of the sphere whose diameter is 14 centimeters, in other words whose radius is therefore 7 centimeters. So from the formula we get the value of the surface area as 616 centimeters square. Okay, so very straightforward. Again, this question is also fairly straightforward. We just have to apply the value of the radius in the formula for the surface area of the sphere. Okay, of course the radius was given indirectly by specifying the diameter. From the diameter we calculated the radius by dividing the diameter by 2. So diameter divided by 2, we get the radius of the circle. This is known to us. Okay, and from that we calculated the surface area of the sphere. The next question is we have to find the total surface area of a hemisphere in this case, whose radius is given as 10 centimeters. So the radius r is 10 centimeters. R equals 10 centimeters. And we are asked to use the value of pi as 3.14. So we'll use that value. So what is the total surface area of a hemisphere. The formula for that is 3 pi r square. So we'll just apply the formula and substitute the value for pi and for the radius r, and we will be able to get the answer for the total surface area. So 3, and we have to use the value for pi as 3.14. The radius r is 10 centimeters, so that's 10 into 10. So basically 10 into 10 is 100. 3.14 into 100 will become 314. So that will be 3 into 314, and that will give us the value for the total surface area of the hemisphere, which should be 942 centimeters square. So 3 into 314 is 942 centimeter square. Okay, so again, this is also a fairly straightforward problem where we just had to substitute the value of the radius in the formula for the total surface area for the hemisphere. Okay, so you just need to remember the different formulae. So the surface area of a sphere is 4 pi r square. The curved surface area of a hemisphere is 2 pi r square, and the total surface area of a hemisphere is 3 pi r square. Okay, if you just remember these formulae, it is fairly straightforward. You can just apply the values of the parameters given and get the value of the surface area. Well, let us now move on to the next question. In the next question, we are given the radius of a spherical balloon increases from 7 centimeters to 14 centimeters as air is being pumped into it. We are asked to find the ratio of the surface areas of the balloon in the two cases. So we have a sphere of radius 7 centimeters and another sphere of radius 14 centimeters. So for each of these radii, we can calculate what's the surface area. And then we have to find the ratio of those two surface areas, which is fairly straightforward. So we are given two radii. So let's call the first radius as R1. So R1, we will call it as 7 centimeters. And then we'll call the second radius R2, and that is 14 centimeters. Okay, these are the two radii given to us. So we have to find the ratio of the surface areas of the spheres for these two cases of the radius. So surface area with radius R1 equals 4 pi R1 square. Okay, whatever is the value of R, we have substituted in the formula for the surface area of the sphere. So 4 pi r square. The value of the radius r is R1 here. We'll substitute the value of R1 later on. So just write the general case. The surface area of the sphere when the radius is R1 is 4 pi R1 square. Similarly, the surface area with radius R2 will be 4 pi R2 square. Okay, so we have the two surface areas now. Surface area when the radius is R1 and the surface area of the sphere when the radius is R2. So we want to find the ratio of these two surface areas. So let me write ratio equals. So I'm going to write surface area as in short form as SA. So we want to find the ratio. So we have to write it as with radius R1. So because you want the ratio, we say divided by surface area with radius R2. So now we know the surface area formulas for each of them. So it will be 4 pi R1 square divided by 4 pi R2 square. So you see the reason why I did not substitute the value 7 in place of R1 and 14 in place of R2. We could have done that. We could have substituted the value of R1 as 7 centimeters and obtained the value for the surface area when the radius is R1. And then similarly substitute R2 as 14 centimeters and obtained the surface area value by simplifying that and then taken the ratio. But doing it this way makes the calculations easier, because we see now when we are doing the ratio, the 4 and 4 will cancel out, the pi and pi will cancel out, so we will be left only with r1 square by r2 square. So the calculation will be much easier. So 4 and 4 will cancel, pi and pi will cancel, so we are left only with r1 square and r2 square in our formula now. Okay, so that's r1 square divided by r2 square. So we know r1 is 7 centimeters, so that will be 7 square is nothing but 7 into 7 divided by r2 is given as 14 centimeters, so that will be 14 into 14, and we can simplify this. So the 7 will go here 2 times, so 7 goes here 1 time, and this 7 1 here and 2 here. So we have 1 into 1 by 2 into 2, which is 1 into 1 divided by 2 into 2, which is equal to 1 over 4. So the ratio of the surface areas is 1 over 4. Okay, so when we are given some parameters and asked to find the ratios, it is always much easier with the calculations if we keep the formulas as they are, and then write the ratios in terms of the formula itself. So you'll have some common terms which will get cancelled out in the formula in the numerator and denominator, and then you'll have much lesser numbers to perform your calculations. So the calculation will be much easier. Had we computed the surface area by substituting the value of r1 here, we would have got 4 pi into 7 square. That would have given us an answer of 616 centimeters square. Similarly, for the radius r2, the surface area would be 4 pi into 14 square, and that would have given us a value of 2464. And then if we take the ratios, 616 divided by 2464, that will give us the same answer, 1 by 4. Okay, but unnecessarily we would have had to calculate 4 pi r1 square, 4 pi into 7 into 7, and again here 4 pi into 14 into 14 to get the two values of the surface areas and then take the ratio. So but instead we have done it with a much easier way, whereby it minimizes the calculations, because the 4 and 4, the pi and pi get cancelled out, so we are just left with the ratios of the squares of the radii, so r1 square by r2 square. So the calculation is much simpler in this case. Okay, either way is okay to do it, but this is much simpler in terms of the calculations. Okay, now let's move on to the next problem. Okay, that's question number 5 from exercise 11.2. Now we are given a hemispherical ball made of brass, has inner diameter 10.5 centimeter. We are asked to find the cost of tin plating it at the rate of rupees 16 per 100 centimeter square. So we are given an inner diameter. From the inner diameter, we can divide the diameter by 2 and get the inner radius. And once we have the inner radius, we can calculate the inner curved surface area. Because it's a ball, it is not having a covering on the top, so it's a hollow ball, so we need only the curved surface area. So once we calculate the curved surface area, from the total curved surface area, we can calculate the cost of tin plating it, because we know what is the cost of tin plating 100 centimeters square. So based on this, we can calculate what is the cost of tin plating the entire inner surface of the ball. So let's first write down the given parameters. So we are given the inner diameter. Let's call that as D, as 10.5 centimeters. So therefore the inner radius let's call it R. That will be D by 2. Radius is half of the diameter, so that will be 10.5 divided by 2, which should be 5 let me write that 5 clearly, 5.25 centimeters. Okay, so we now have the inner radius of the hemispherical ball. Now we need to calculate the inner curved surface area for the hemisphere. So the formula for the curved surface area for a hemisphere is 2 pi r square. So we just need to substitute now. So it's 2 into pi is 22 by 7 into the radius is 5.25 square, so we have to multiply it twice. 5.25 into 5.25. So calculating this will give us the inner curved surface area of the hemispherical bowl. So we get the value of the inner curved surface area as 173.25 centimeters square. Okay, so we have got the inner curved surface area value, and we are now given that the cost of tin plating 100 centimeters square is rupees 16. So let's write that. So we have the value for the cost of tin plating 100 centimeters square as rupees 16, which is given in the question. From this we can calculate what is the cost of tin plating 1 centimeter square, which will be 16 divided by 100. So we have now calculated what is the cost of tin plating each centimeter square. So that is the cost of tin plating 100 centimeter square divided by 100. That gives us the cost of tin plating 1 centimeter square. Now that we know the cost of tin plating 1 centimeter square, we need to calculate what is the cost of tin plating the entire curved surface area, which is 173.25 centimeter square. So basically we are going to multiply the cost of tin plating 1 centimeter square with the curved surface area of the inner hemispherical ball. Okay, so the cost of tin plating 173.25 centimeter square will be 16 by 100, which is the cost of tin plating 1 centimeter square, multiplied with the curved surface area, which is 173.25, and that will give us the cost of tin plating the inner part of the bowl, which when you calculate this, we get a value of 27.72. Okay, so the cost of tin plating the inner part of the hemispherical bowl with this particular diameter is 27.72 rupees. Okay, so what we did here is from the diameter we obtained the radius, and then we calculated the curved surface area of the inner part of the hemispherical bowl, and then we used the information regarding the cost, which was given as 16 rupees per 100 centimeter square. From that we got the cost for 1 centimeter square by dividing the 16 by 100, and then we multiplied the cost of 1 centimeter square with the area of the surface, and that gave us the cost of tin plating the inner surface of the hemispherical ball. Okay, so again, this is also a simple problem. It involves a few steps and applications of certain concepts which you have learned in your previous classes, in your classes 7th and 8th and so on. Okay, now let us do one more problem from this exercise and finish this video, and for the remaining questions in the exercise I will be making a separate video. Okay, so the next question is question 6 from exercise 11.2, where we are asked to find the radius of a sphere whose surface area is given. So the surface area is given to us and we have to find the radius. So let's write what is given. Surface area of sphere is given as 154 centimeter square. We are asked to find the radius of that sphere. So we know the formula for the surface area of a sphere is 4 pi r square, and that is given to be equal to 154 centimeter square. Okay, so how to find r? So we have 4 pi r square equals 154. So 4 into 22 by 7 into r square equals 154. So we just keep the r square on the left side and take all the other all the other numbers to the right side of the equal sign. So we will have r square as 154 into 22 by 7. When we take it to the other side, it will become 7 by 22, and the 4 which is in the numerator here, when it comes to the other side, it will come to the denominator, so that will be 4. I'll put it here. Okay, so 4 into 22. So we just need to simplify this, and we will get the value of r square. So we know that we can see that 22 goes into 154 7 times. So we have 22 7s are 154. So we have the value of r square as 7 into 7 divided by 4. So just to make our calculation simpler, I'm going to write this r square as 7 into 7 divided by the 4. We can write it as 2 into 2, right? So basically this is 7 by 2 the whole square. Okay, just to make the calculation of the square root easier, we have written it this way. So we are getting 7 into 7 on the numerator. The denominator is 4, which we can write as 2 into 2. So we can represent this fraction here as 7 by 2 the whole square. So it is 7 into 7 by 2 into 2. So now we want to find r. So r is the square root of 7 by 2 the whole square. So 7 by 2 the whole square under the root. So because we have square and root, they will cancel out each other. So we get the answer as 7 by 2, which is 3.5 centimeters. Okay, so this is what we have done here. We have just performed this step here to make our computation of the square root easier. Okay, so if r square is 7 by 2 the whole square, then r is simply going to be 7 divided by 2, which is 3.5 centimeters. Okay, we'll stop here for today, and we will continue with the next few problems in this exercise in a separate video.